This is the shape of an earth. It is bulging at the equator and compressed at the poles. Why it is bulging at the equator? Because it is taking a spin. It is taking a spin. So because of continuously spin motion is there, in that there is one force which is called as centrifugal force, which makes the equator bulged and compressed at the poles. Understand? So this is the shape of an earth here now. So once you get to understand the shape of an earth, what do you understand here? Say radius at the equator and this is radius at the poles. So radius at the equator is greater than radius at the poles. Radius at the equator is greater than radius at the poles. You should understand these points here now. So one more thing you should understand is what is this called as? See, this is called as major axis. This is called as major axis, and this is called as minor axis. Okay, and this is, if you take sagam 50%, this is called as semi-major axis. This is called as semi-major axis, and this is called as semi-minor axis. Hope you are understanding what is the total structure of the earth here now. So let us go ahead now further regarding the remaining part of the earth here now. This is the earth having a mass capital M, and let us imagine that you have kept a certain small ball on the surface of the earth. You have kept a small ball, and this ball is having mass small m, and the distance between these two is considered as, okay, the distance between these two is centers is taken as radius of the earth here. Now see, there is one small point we should understand here according to the Newton. Okay, so wherever you go, Newton is not going to leave you. Newton's law of gravitation. Okay, Newton is such a scientist that in every chapter he will keep his fingers. ప్రతి chapter లో ఏళ్ళు పెట్టినాడు. Understand? So Newton will not leave you. Newton's law of gravitation, what did he say? You know, in the universe, every body attracts some other body. Smaller bodies revolves around the larger bodies, and there is a force of attraction between two bodies always. And if larger body, if you consider, smaller bodies are revolving around the larger bodies. Like sun, if you consider larger body, earth is revolving around the sun, planets are revolving around the sun, and moon, if you take, moon is smaller than the earth and moon is revolving around the earth. This is called as law of gravitation. Okay, so all bodies in the universe attract some other body. Then one of the students stood up and asked me the doubts. Sir, if all bodies are in the universe are attracting some other bodies, we are also bodies of universe. My and my friend, why they are not attracting? Why he is not sticking to me? Then I said, your doubt is reasonable, logical. Your doubt is very funny, but it's a real logical doubt you are asking. It makes some sense. Yeah, you are right. But compared to the masses of sun and earth, your masses are negligible. Your masses are very small. That's why the force of attraction between you and your friend is negligible. There is attraction, but it is not so strong that your friend is coming and sticking to you. Always when you want to go away, you have to push him and remove that bond attachment and go somewhere. It is not there. You are going this way, some lorry is going that way. Whenever lorry passes by you, you stick to the lorry and go along with the lorry. It's not that much strong force. Negligible. Why? Your mass is 50 to 70 kg. What is the mass of the earth? What is the mass of the sun? What is the mass of the moon? Nothing. Your mass is nothing before that. Stronger masses have greater forces. That's why we write force is directly proportional to product of the masses. Product of the magnitude of the masses. Larger the masses, larger the force. And force is inversely proportional to square of the distance between them. If you join these two, you get force is directly proportional to m1 m2 by r square. F is equal to capital G m1 m2 by r square. These are the formulas which you have to learn now. This is called as Newton's law of gravitation. Okay, Newton's law of gravitation, and you just understand that this is called as gravitational constant. This is called as gravitational constant. Let us apply this gravitational constant on this body. Okay, let us apply gravitational constant on this body. How are you going to apply here now? Let us see here. According to Newton's law of gravitation, F is equal to G m1. M1 means capital M. M2 means small m. And the distance between the two bodies, distance between the two bodies means what? One body, another body, the centers can be joined like this with R. This is having mass m1, this is having mass m2, and the distance between them is R. Then this is the formula you're going to apply. This is the different two bodies. Now, different two bodies is, one is Earth, another is some small body like stone or ball, whatever it may be, whose mass is negligible, whose radius, if you consider the radius of that small ball, which is considered as smaller, can be taken as a 2 centimeters or 3 centimeters maximum. But what is the radius of the Earth? It is going to be 6,400 kilometers. 6,400 kilometers is very large compared to the radius of this ball. So we neglect the radius of the ball, we take only radius of the Earth as the distance between the two bodies. So that's why we take distance as capital R square. We are applying Newton's law of gravitation on this concept, where one ball is present on the Earth and that ball is attracted by the gravitational force towards the center. Then we can write here, according to Newton's second law. Newton's second law says that F is equal to m into A, but A is taken as acceleration, is taken as acceleration due to gravity. Okay, so therefore we write this as F is equal to m into G. This is 2, this is 1, and both the laws are explaining. Both the laws are explaining about the force only. Both the laws are explaining about the same force. So we can make LHS as equal, means we can make RHS also equal. Mg is equal to G capital M small m by R square. So what do you understand from this? You understand that masses can be cancelled. So G is equal to capital G capital M by R square. So G is directly proportional to mass. G is inversely proportional to R square. G is directly proportional to mass. G is inversely proportional to R square. What do you understand from this? See, larger masses are having greater gravitational forces. Smaller masses are having lesser gravitational forces. Where radius is more, gravity is less. Where radius is less, gravity is more. From this, it is understood that here gravity at the equator is lesser than gravity at the poles, because I just told you G is inversely proportional to R square. Where radius is more, gravity will be less. Where radius is less, gravity will be more. That's called as inverse relation. Hope you're understanding what I'm saying now. Is it clear? Is it clear? So we got the relation. What did we get here now? We got the relation between small g and capital G. We got the relation between small g and capital G. Understood? Now, okay, if this is the situation, what happens to acceleration due to gravity when you go to certain height? Okay, so I have taken an earth. Okay, I have taken an earth where on the surface of the earth the formula is G is equal to Gm by R square, where radius is going to be R. But when you go to a certain height here, what is taken as the acceleration due to gravity at certain height? That can be taken as Gm by R plus H whole square. G on the surface is this Gm by R square, where m is said to be the mass of the earth here. Okay, at certain height if you take, you have to add R plus H whole square. Is it understood? What? Now I'll take the division of G by GH. So G by GH, if you consider, what is left now? R by R plus H whole square is left. Gm gets cancelled. Okay, GH inversely proportional to R plus H. GH numerator, R plus H denominator. G inversely proportional to R. G in the denominator, R in the numerator. R square. So combined together I have taken R square here. So what do you understand from this? GH is equal to G into R by R plus H whole square. This is going to be your formula. This is going to be your formula, that is called as, what is G at certain height? This formula is applicable for larger radius. For example, larger heights. For example, height, what is acceleration due to gravity at certain height, which is equal to 3200 kilometers an hour. Then we need to apply this formula. There GH can be taken as G into R. R is 6400 kilometers. divided by 6400 plus 3200 kilometers. Okay, and g on the surface, how much it is going to be? G at the surface. So g at certain height, g at certain height is nothing but 9.8 into, if you calculate, you'll get what is the acceleration due to gravity at certain height. This formula is applicable for larger heights. Larger heights like 32,000 kilometers. But if you use what is acceleration due to gravity at just 32 kilometers, not 32,000 kilometers, then we don't use this formula. We don't use this formula. We use different formula. What is the different formula? We shall discuss about that. So that different formula is coming from the same formula, that is h. What is that? R by R plus h whole square. So you just modify this formula g and we write this as 1 divided by R plus h by R whole square. Understood what I have done now? Just R I have taken in the denominator. So what I am going to get now, GH is equal to G, this can be written as 1 by 1 plus h by R whole square. So GH can be taken as G, this comes to numerator, becomes 1 plus h by R power of minus 2. Okay. Understood? Understood why I mean? Power of 2 becomes power of minus 2. See, you should know one thing. According to binomial theorem, 1 plus a whole power n is approximately equal to 1 plus na. 1 plus a whole power minus 1 is approximately equal to 1 minus na. This is called as binomial theorem. The power comes to inside, then this formula will change a little bit. All the changes you are going to observe in this formula is g into 1. This minus 2 becomes minus 2h by r. Power is not there. Power comes inside now. Okay, this is a power comes before coefficient of a. Understood what I am saying now? So this is according to binomial theorem. So I got a new formula now. What did I get now? I got a new formula. This formula applicable for smaller heights where h is equal to 32 kilometers. That formula you can't solve by using this formula comfortably. 32 by 6,200 kilometers plus 32 whole square. What is this drama? Useless. How can we solve that smaller? This formula doesn't work for smaller heights. It's only for larger heights. This formula works for smaller heights because there is no power here. Easy. So G is equal to GH is equal to G into 1 minus 2 into 32 divided by 6400 kilometers. So this is 64 1 times 64 100 times. How easy to solve this one? 9.8 100 minus 1 by 100, which is nothing but 99 by 100 into 9.8. You will get something like 9.6 or 9.5, whatever it may, I don't know. You do calculation, get the answer. Okay. So I hope you understood what I'm saying now. G at certain height, there are two formulas. Now we shall discuss about what happens when you go at certain depth. What happens when you go to certain depth here? Now, so I have taken the earth. Now I got the formula already. G at certain height, G on the surface. If you observe, what is the formula for G on the surface? G on the surface is Gm by r square. Now you have gone to a depth d. Okay, if you have gone to depth d, you should remember one thing. This earth is now this much part. If you take a body, any body, if you take whatever the body you want, you take that body. You have taken a body at this place of mass small m. You have taken that body inside the earth now. The body which was on the surface of the earth, you have taken that body inside the earth now. What happens? What happens? See, you should remember one thing, that okay, this part of the earth is not going to attract this mass. This part of the earth is not going to attract this mass. Only this part of the earth is going to attract when you go inside. Understand? When you go inside. Outside part, when you have entered here, this part doesn't attract. Only this much part which is inside the green color is going to attract. And what is the mass of that? The mass of that can be considered as m dash. Okay, this is called as Okay, so this is called as m dash, and the total mass is considered as m here. Now, so what do you understand from this? If this is d, what is the remaining height? Is it not r minus d? Mottam r minus d. This much part is r minus d. The radius of the inner part of the earth, which is going to attract the body when it has entered, is taken as r minus d here. Okay, so now you all know mass is equal to volume into density for larger body, and this volume is taken as V dash. So mass can be taken as volume, which is 4 by 3 pi r cube into rho. So I just write here G. M means 4 by 3 pi r cube rho by r square. So what's going to happen now? R square r cube gets cancelled. G is equal to 4 by 3 pi r rho. Sorry. Pi rho gr. Pi rho gr. So we got a new formula here, isn't it? Okay, we got a new formula for g on the surface. G on the surface. We got a new formula. We got a new formula for the surface of a body when you take mass as volume into density. Is it? Understood what I am saying now? Now you just see what is going to happen now. G at certain depth, at this place you want to find out G at certain depth, which is going to be G m dash by r minus d whole square, isn't it? Same Newton's law of gravitation, whatever we have derived, we are applying for smaller masses. We get this formula, isn't it? So what is mass m dash here now? M dash is nothing but V dash into rho. M dash is nothing but V dash into rho, volume into density. Mass is nothing but mass is volume into density, smaller mass, smaller volume. Density of the earth is same, whatever it may be, inside the earth, outside the smaller part. But inside whatever it may be, density is going to be uniform, is going to be same. So we have written this one. So mass M dash for smaller volumes, we write 4 by 3 pi r minus d whole cube into rho. Do you understand what I am saying now? Volume of a smaller green color surface of the earth which is going to attract the body when it is inside. Then that's going to be mass m dash 4 by 3 pi r cube means you take this radius r minus the whole cube into rho. Okay, so you just substitute that. You just substitute that here. Now what are we going to get? Let us see here. So GD is equal to G. M dash is nothing but 4 by 3 pi r minus d whole cube into rho divided by r minus d. Okay, so r minus d whole cube divided by r minus d whole square. So what do you understand from this? This is getting cancelled, this cube gets cancelled, then what is left here? So GD is nothing but 4 by 3 pi G rho r minus d is going to be the formula here. Is it understood what I am saying now? So G at certain depth, this is the formula, and G on the surface, what is the formula? 4 by 3 pi G rho r is going to be the formula. So this is considered as equation number 1, and this is considered as equation number 2. So therefore we write 2 by 1. So what are we going to get now if you take 2 by 1? So GD Papu. GD by G is equal to M मिलता. So what is left now? R minus D by R is left. Everything gets cancelled here now. So GD by G is equal to 1 minus D by R. So GD is equal to G into 1 minus D by R. Understood? So G at certain depth, the formula is ready. Okay. What is the formula which is ready for G at certain depth? This is going to be the formula. Understood what I am saying now? So G at certain depth, this is going to be the formula. Yes, is it clear what I am saying now? So this is about the what happens to gravitation at certain heights and what happens to gravitation at certain depth. In general, what do you understand? What do you understand to G? What happens to G when you go to certain height? Will it increase or decrease? What happens to G when you go to certain height? Will it increase or decrease? It decreases. Why? Because denominator is increasing, no? Radius is increasing. But when you go inside, what happens? See, there are two formulas here. There are the two things we have to understand here. See, when you go to certain height, radius will come into action here, because when you go to certain height like this, radius increases, denominator increases, g is inversely proportional. So as you go certain height, g decreases. But what happens when you go to certain depth? When you go here, what happens? Will g decrease or will increase? Hey, shut. Wrong. G decreases even when you go depth. G is maximum on the surface. Why is it so? Because when you go inside, G is directly proportional to M. When you go up, G is inversely proportional to R square. R square here, sorry. Okay. So when you go at certain height, you have to consider radius as a physical quantity. When you go at certain depth, mass is considered a physical quantity, because as you go depth, mass of the earth which is going to attract will decrease. G decreases at certain depth. G also decreases when you go to certain height. G will be maximum on the surface. Hope you understand what I am saying now. ఎందుకు తగ్గుతుంది లోపలికి పోతారంటే మాస్ తగ్గిపోతుంది లోపలికి, పైకి పోతే ఎందుకు తగ్గుతుంది? రేడియస్ పెరుగుతుంది. ఒకటి ఇన్వర్స్ రిలేషన్, ఒకటి డైరెక్ట్ రిలేషన్. బోత్ ఎలా పోయినా డిక్రీజెస్ ఓన్లీ. On the surface only it is going to be maximum. Hope you understand what I am saying now. Let us go for the next thing. Here, what is the variation of G with angle of latitude atom? What is the meaning of variation of G with angle of latitude? See here what I am going to say now. See, this is the earth. Now this is going to be the equator. Okay, so you are at this place now. You went here. What happens now? Let us take this angle is phi. What happens when you have traveled towards the pole from the equator? You have traveled certain angle theta, certain angle phi antam then phi. So when you move from equator to that point, what happens to G? Will it decrease or will it increase? Will it decrease or will it increase? అంటే ఏదైనా కావచ్చానే. మాకు కెమిస్ట్రీ లెక్చర్ ఉండరా ఆయన, ఏం పేరు అయింది బా, ఎంత డేంజర్ అంటే ఆయన క్లాస్లో చెప్పలేదనుకో ఆన్సరు, బాబ్బా మూతి మీదనే కొడుతాడు ఆయన. పేరు గుర్తురావట్లేదు, రంగారెడ్డి సార్, చాలా ఫేమస్ ముసలాయన, కోల్స్ కాలేజీలో లెక్చరర్ ఆయన. ఆయన ట్యూషన్ పోతుంటే ఆయన ఏమి, సో క్లాస్లో చెప్పేటప్పుడు పలకాల మనమంతా, ఏమో అర్థమయ్యా చెప్పు, ionization energy, the minimum energy required to remove an electron from an orbit when the atom is in neutral gaseous state. Gaseous అంటే మన గ్యాస్ వస్తుంది కదా ఆయన భయంతో, అవునా కదా, గ్యాసియస్ స్టేట్ అంటాం. ఇప్పుడు మాకు అర్థమై సావదు అది ఒకటేసారికి ఆయన చెప్పమంటాడు. ఏం చెప్పలేనుకో, ఎవరన్నా ఊపి కూర్చున్నాను, ఎరా పలకట్లేదు నా ఎలా ఇట్లా పలకట్లేదు గాడిన ఎలా, అమ్మ బాబోయ్ నోరు మూసుకుంటే చంపుతాడు అనేసి ఏమంటుంది తెలుసా, అర్థమైన కదా, సెంటెన్స్ ఫార్మేషన్ తెలుగు పోయినా కూడా ఇంకా అంటే ఎందుకంటే అందరిలో నలుగురితో నారాయణ సౌండ్ కలిసిపోతుంది కదా. అయనేషన్ ఎనర్జీ డెఫినేషన్ అర్థమవుతుంది అందరిలో. 10 మంది అడిస్తే మనకి ఏమర్థమవుతుంది, వాళ్ళతో వాళ్ళు వెరీ గుడ్ అర్థమైనట్లే నీకు, ఎరా ప్రకృతి అర్థమైనట్టు, ఈరోజు బాగా వస్తున్నావు, బాగా చెప్తున్నావు ఆన్సర్లు అర్థమైనట్టుంది. అమ్మ సచివ అంటాం. సో వెరీ ఫన్నీ, చాలా డేంజర్ సార్, చాలా డేంజర్, భయపడి చచ్చిపోతుంది మేము. ఓవర్ యాక్టింగ్ అనిపిస్తుందా ఏమన్నా, కొంచెం ఓవర్ కనిపిస్తుంది కదా, అడ్జస్ట్ చేసుకో, అలవాటు కావాలి కదా నువ్వు కూడా నాకు. సరే, సో వాట్ ఈస్ గోయింగ్ టు హ్యాపన్ హియర్, లెట్ us see. Next thing is, see, so when you keep any body here, how does it rotates? It rotates like this because earth is taking a spin kada. So this is an axis, so earth is taking a spin like this. So this upper body will rotate in this circle. Am I right or not? This upper body will rotate like this. Then what happens to G at this place at certain angle? Phi. For that, what I am going to do now? I will draw one line here. I will draw one line here. And that radius is taken as smaller. This is called as scapular. If this is phi, this is also going to be phi here, is it? That is also going to be phi here. What is the force which is acting in this direction? That is called as centrifugal force. Any body is rotating on this body which is kept on the earth, the surface of the earth at certain angle phi at this place. One force will act which is called as centrifugal force, Fc. So if this is Fc, exactly in this direction, these two angles are going to be same. That is called as phi here. That is called as phi here. Now just see. So try to understand what I am saying now. If this body is kept here, now it rotates in a smaller circle, not along the larger circle. This is a smaller circle whose radius is r. The larger radius of the actual radius of the earth is capital R. So this is Fc. Okay, Fc means you have to consider in this direction. In this direction from the center, this is going to be Fc cos phi. Fc cos phi. The component, this is Fc means that is Fc cos phi. But what is Fc? Fc is considered as m smaller omega square because the earth is revolving around an angular velocity omega square. Very simple. Very simple explanation. This one, don't get confused. If you don't understand, ask once again. What is going to happen? Let us see here now. So here, Fc, which is called as mr omega square, will act in this direction. So, but you should know one thing. What is that? Cos phi is equal to adjacent side by hypotenuse, because this is a right angled triangle. This is a right angled triangle A, B and C. So therefore small r is equal to capital R cos phi. So I can write now this Fc as capital R omega square cos phi. Understand? Is it clear what I am saying now? Huh? Is it clear what I am saying now? So what is going to happen here now? This we are right now Fc cos phi. What is the meaning of Fc cos phi now? See, already Fc means this much. Again one more here. What is this Fc now? Fc cos phi harmonic. The force which is acting is called as Fc cos phi means what we will write? Fc is this one, mr omega square cos phi is there, one more cos phi, that means cos square phi is called as acting in this direction now. See here, one force is acting away and let us take the net force acting in this direction is mg dash. See what I am explaining now. See, already there is one force acting towards the center, that is called as mg. Okay, the force which is called as, this force is called as force due to gravitation. Okay, let me explain separately what is going to happen here. Just see. So in this direction, what force is acting here? Let us take the free body diagram. Let us take the free body diagram of that, so that the explanation will become very easy, not this much clumsy. Okay, so what is going to happen now? I have taken that body and placed here. What are the forces acting in this direction? Fc cos phi. Fc means mr omega square cos phi. So this in this direction, mr omega square cos square phi is acting in this direction. In this direction, one force is acting which is called as mg. Weight, gravitational force. We can call this as gravitational force. Okay, this is also working. This is also working. Which is dominating? Which is dominating? Gravitational force is dominating Fc. If this is dominating, then only it will stick there. If that will dominate, it will fly off. Okay, Earth is spinning, then also we are on the Earth. Means what does it mean? Gravity is stronger than centrifugal force. What that is the meaning, isn't it? So here, this force is also acting, this force is also acting, but this is larger. That's why I have taken longer vector. This is a smaller vector. That means what is the resultant force? Resultant force, let me consider as mg dash, which is towards the dominating force. So therefore, mg dash is nothing but mg minus mr omega square cos square phi. Hope you understand what I'm saying now. Is it clear? So from this you will remove m and m. So g dash is equal to g into 1 minus sorry, g minus r omega square cos square phi. We got this as a formula. Okay, g dash, what is that? G dash, g dash anna teesko ledante you can consider g at certain angle phi. Okay, g at certain angle phi, that is called as g phi. So therefore we get g phi. G at certain angle of latitude is g minus r omega square cos square phi. So you apply this as a formula here now. This is the formula which I have got this one. So let me explain once again here. In a brief, within 2 minutes, I'll revise once again, try to understand and remember what I am saying, because it's a little bit confusing, but not so much confusing that you get panic like that. So easy. See, this is the earth. Earth is taking a spin. You have taken any body from this place to that place at certain angle. Okay, this body was here, I have taken upwards like this. It is making angle phi here. So when you transfer the body here and earth is taking a spin, on that body there is one force which is acting away from the center of the circle which is rotating, that is called as Fc, centrifugal force, which is called as mr omega square. So this is Fc, but this is angle phi, this is also angle phi, because these are parallel lines, these are alternate interior angles, they will be same here now. So when you extend this line, these two angles are called as vertically opposite angles, they are also going to be same. So this is Fc, which is mr omega square, means in this direction Fc cos phi, the component of Fc. Already, what is the meaning of Fc here? Fc means mr omega square. But what is the relation between smaller and capital, which is called as radius of the earth, and smaller is the radius of the smaller circle surrounding which this mass is rotating in a smaller circle. So cos phi is adjacent side by hypotenuse, smaller by capital R. So smaller is going to be capital R cos phi. So wherever you get smaller, you get capital R cos phi you have added here. Okay, already Fc under inta, mali Fc cos phi inkoka value ochindi. Fc cos phi means this cos phi, that cos phi becomes cos square phi. Understand what I am saying now? So what is that you are getting now? There you are getting this value. So already this value is there. If you keep Fc here, one more cos phi will be added here. Fc cos phi, mr omega square cos phi into cos phi cos square phi is the force which is acting in this direction. I have taken the total system separately. Free body diagram. Okay, so I have taken that point here. There mr omega square cos square phi is acting in this direction. Mg is acting towards the center of the earth always, which is called as weight of a body or force due to gravity in this direction. That force is also acting, this force is also acting. Even earth is taking a spin, this force is present, we are not flying off into the universe. We are sticking on the earth, you are standing here means you are sticking on the earth. Why you are sticking on the earth? Because mg is dominating mr omega square cos square phi. This is dominating. That's why resultant force is towards mg only. Resultant force means what? mg phi, resultant force. Okay, so resultant force is nothing but mg phi, which is the difference of these two forces. So therefore resultant force at mg minus this value, which is mr omega square cos square phi. So what is fr, resultant force, which is called as mg phi? Mg minus mr omega square cos square phi, gets cancelled when you common out. You're getting this one now. So what is G5 at the equator? Equator means enta value. See, at the equator, phi will become 0 or not? Tell me. If you take at the equator, what is an angle here? Yes. What is an angle at the equator? It is going to be 0. If it is going to be 0, what is G5? Okay. So G0 is nothing but G minus R omega square cos square 0. Cos 0 is 1. Cos 0 is 1. So we write G at 0. 0 ante at equator and equator meeda. So G minus R omega square is going to be your answer. Okay. So what is G at the poles? G at the poles means G at 90 degrees. Okay, G at 90 degrees, because when you take G at the poles, this angle increases, it becomes exactly 90. So here G5 means G90 here. Okay, So G 90 degrees is equal to G minus cos 90 is going to be 0. మొత్తం ఎగిరిపోతుంది, G ఒకటే మిగులుతుంది ఇక్కడ. So this is going to be G 90 and this is going to be G at the equator. Then what is the difference between these two? Okay, so if you want to find out the difference between these two, how will you do? See, delta G, changing the value of G from equator to the poles. Which is larger now? Here gravity is larger, I told you. Gravity will be more here. Why? Because radius is less. Huh? I told you that G is equal to Gm by r square. G is inversely proportional to r square. Radius is less, G is more, and radius is less. Huh? Radius is less at the poles. Radius is larger at the equator. So when radius is larger, as G is inversely proportional to r square, here G will be less, here G is more. How much less? Why it is less? I have explained here. Why it is less? I have explained here. Why? See, G at equator is G minus r omega square. G undadu, daniki r omega square to subtract cheyali. G at the poles is maximum, which is G. Now I want the difference. Means G at the equator, which is larger here now? G at the poles. So G at the poles minus G at the equator gives you the change in G. So change in G, so delta G is going to be G at the poles is G at the equator is how much? This one, G minus R omega square plus. So G gets cancelled. So delta G is nothing but R omega square. Find the change in the value of G when you move from equator to the poles, means your formula should be R omega square, where R is said to be how much? Radius of the earth. Then what is omega? What is omega, my dear? So how do you find out the omega for the earth which is going to take a spin like this? Which angular velocity omega? See, omega is nothing but 2 pi by capital T. You can find out omega for the earth. Okay, here one more thing I'll tell you. One more logic I'll tell you. This type of problems are asking regularly. What type of problems? Find out angular velocity of a seconds hand. Seconds hand. Whatever it may be, angular velocity formula is theta by small t, angular displacement of time. For one complete revolution, theta will become 2 pi, small t will become capital T, omega will become 2 pi by capital T is going to be the formula here for omega. Understood? Angular velocity and angular displacement of time. For one revolution, theta is 360, which is nothing but 2 pi, and t is going to be time period, which is taken as capital T. So 2 pi by capital T is going to be a formula for angular velocity. For what is an angular velocity for a seconds hand? Seconds hand means 2 pi. How much time it will seconds hand will take for one revolution? 60 seconds. Okay, so 2 pi by capital T plus 60 seconds. So angular velocity of a seconds hand is how much? Pi by 30 radians per second, because theta is in radians, time is in seconds. Okay, so what is an angular velocity of a minute hand? The same formula, 2 pi by capital T. So minute hand, how many minutes it will take to take one revolution? This is 60 seconds, but this is 60 minutes. So your answer should be 60 into 60, because 60 minutes into 60 seconds gives you the total answer in seconds, because we want the answer in radians per second. So therefore angular velocity of a minute hand is how much? To 1 times to 30 times is going to be pi by 1800 radians per second. Somebody sounded like this. Sound? Sound आया हो? क्या? ऐसा. Next. So angular velocity of our hand. Hour అంటే మనది కాదు, అవర్ అనకూడదు కదా, హెచ్ సైలెంట్. అవర్ అంటే ఎంత టైం తీసుకోండి? 1 hour, 12 hours. Our hand will take 12 hours to take one complete revolution. So this is time period, no? Time taken for one total revolution. This is how much? 2 pi by how much? 12 hours. 1 hour means 60 minutes. 1 minute means 60 seconds. You have to write the calculation and simplify this one and get the answer. So this is going to be the angular velocity of our hand. Then what is an angular velocity of the earth? Angular velocity of the earth, the same thing you write here now. What is that? 2 pi by here you just remember, our hand will take only 12 hours, but earth will take for complete spin 24 hours. So your formula should be 24 into 60 into 60 radians per second is going to be your answer. Hope you understand what I'm saying. Yes. So you have to calculate this one and find the what is angular velocity. So pi means we write 3.14. Pi and 3.14. Some 0.0016 something value is there if you calculate that one. It is a constant. You did not remember that one. There is some value in books it is given. I couldn't remember. I forgot that one. So omega for angular velocity of the earth should be like that. Isn't it? Okay. Okay. One more thing you hear. One more concept is there here. For example, this is the earth. You are staying somewhere here. You are standing here now. You are standing on this position of the earth. Okay. If the earth is rotating with an angular velocity, if the earth is rotating with an angular velocity so speed that you are feeling weightlessness, earth ఎంత స్పీడ్ గా రొటేట్ అవుతుంది అంటే నువ్వు దాని మీద నిలబడినావు ఎక్కడ ఈక్వేటర్ దగ్గర నిలబడినావు ఫర్ ఎగ్జాంపుల్ హియర్ ఇక్కడ నిలబడినావు ఎర్త్ మీద అండ్ యు ఆర్ ఫీలింగ్ వెయిట్లెస్ అంటే ఏమి mg is going to be 0. The acceleration due to gravity on you is going to be 0 at that place. Then what should be the angular velocity of the earth? How much should be the angular velocity of the earth so that you should feel weightless? So what is our formula here? G phi at the equator is how much? G minus enta r omega square cos square phi. Cos 0 is 1 and cheppana. So cos square phi, cos 0, because at the equator angle phi is 0. So this part goes. Understand? This part goes. Now I am multiplying with m on both sides. What I will do? I will multiply with m on both sides. M and m and m. Okay. So here at the equator you are feeling weightless. Weightless means this part is going to be 0. M into g is going to be 0. So here m if you common out, it is also getting cancelled. It is going to be 0. So what is left now? G minus r omega square is left. So you write r omega square is equal to g. Omega square is equal to g by r. Omega is equal to root of g by r. So t, omega is 2 pi by capital T, which is nothing but g by r. So t is equal to 2 pi root of r by g. Okay. So what is this? This is going to be the time period of the earth when you feel weightless at the equator. When you are feeling weightless, what should be the angular velocity of the earth means? This is going to be the formula. And what should be the time period so that you feel weightless? This is the formula. Understood what I am saying now? So t is equal to 2 pi root of r. R means 6400 kilometers. If you want to convert into meters, 6400 into 1000 meters divided by g. G అంటే 10 తీసుకోవచ్చు లేదా 9.8 meters per second తీసుకోవచ్చు. So you calculate that one. Okay, so if you calculate that one, you have to find out what is the time period of the earth so that you feel weightless. Understood? So this is the total concept of the earth. Now we shall discuss about one more concept which is called as Kepler's first law. Time and time 9:32. Okay, Kepler's law మిగిలింది ఈ రోజు మేడం రాదు. She went to Vijayawada for her work, some official work. So shall I explain after 2 hours like that so that it will not get clumsy? Okay, समझ में आ रही बात? I can explain now, no problem. If you are ready to listen, I can explain. Kepler's laws, it takes nearly 20 minutes. 20 minutes. You want to listen? Are you ready to listen? मैं बाद में बोलूँ. कुछ तो बोलो. ఏమి చెప్పాలా బోలో ఓకే see at Kepler's first law, see I told you that this is an ellipse. ఏమంటారు somebody said something వద్దా ఎవరో ములిగినట్లు సౌండ్ వస్తే so these are the two centers for an ellipse. The first law says that all the planets like earth revolve around the sun in elliptical orbits. with sun at any one of the foci. Okay, see here, to draw a circle there is one center and this is called as focus. This is called as a focus point. To draw an ellipse, we need two centers, I told you, like this, and join these two lines. And this is in the plural sense. We write it as foci. This is focus. This is called as foci. Understood? Foci and foci and plural. Rendu untayi points. So sun will be either here or there. That's the reason we are getting different seasons. Now, if the earth is here, it is definitely winter. If the earth is here, as it is very close to the sun, it is summer. Now, earth is here, it is going away from the sun. This is the month of June, where slowly it goes away from the earth now. And that's the reason temperature slowly decreases. Temperature slowly decreases because here distance, here distance, here distance will be same. But as you go this point, if you move, is going to be winter season. Temperature slowly decreases. When it goes here, temperature will become very cool. 15 degrees, 20 degrees in our Karnool. Might be there are some places where there is 0 or -10 like that also. No problem. Might be there are some places. Understood? I have seen some places. My friends will say that even if you cry, your tears will come up to here, it becomes ice. Understand? So there people will not cry like this. There people will cry like this. ऐसा ice के टुकड़े निकालना पड़ता. Understand or not? You sneeze, then what happens? Two balls तो पटन पटन नाक छिन गया तो दो बाला निकल कर थोड़ा मार. Understand or not? This happens there. Understood? Okay, there you won't get any water. All snow will be there. Take some snow from outside, keep in a box, you burn, you get a water, you drink the water, remaining water you throw outside. That water before falling, it becomes ice. Understood? So that much cool countries are there. This, like Greenlands, which are very close to the poles. Understood what I'm saying now? So this is about the story of the first law. So let us go for the second law, which is very important, which is very complex and also important. So what is the second law explaining here? Kepler's second law. Okay. So here this is the earth. There is a sun at this place. Okay. Now let us take one month called as April month. Earth is here to here. So I have taken this part. I have taken the area. Now let us take November month, earth is moving from here to here. Then I have taken this area. So let us take this area as DA1 and this area as DA2. Okay. So what do you understand from this Kepler's second law? See, I'll define the second law. Try to understand. I don't write. Just listen what I am saying. The line joining the sun and earth. The line joining the sun and earth sweeps equal areas in equal intervals of time. Here also this is April month, 30 days. Here this is November month, 30 days if you consider. Okay, so this area and this area is same. There is dA1 by dt and dA2 by dt. They are going to be same. What is this, sir? How can it be same? Here it is very close. Here it is very far. This area may be larger. You might be thinking, no. Orange, sorry. So here you just remember one thing. When you go very far, Earth moves very less distance. When it goes very close to the Earth moves in 1 month from here to here. This distance is larger. This distance is smaller. Even Earth does not like to stay near the sun for larger time. So in 1 month it moved here, in 1 month it moved very less. The reason for that is as the earth comes here, attraction will become strong. Fast moving. So what is the motion of the earth surrounding the sun? See this one. Earth is here, no? Understand? Like this earth moves. It moves faster when it is very close to the sun. It moves slow. So 1 month it has traveled lesser distance, but this distance is larger, no, these two areas will become same. Even though this distance is lesser, this distance is larger. That's why the areas is going to be same. Okay, so that is called as Kepler's second law. Now, so what do you understand from this? Like you take what do you take? What is this nonsense? As you take, PV is equal to constant. We write P1 D1 is equal to P2 V2, Boyle's law. Okay, so dA by dt is equal to dA2 by dt means dA by dt is equal to constant. No, you have to find out the area. So how do you find out the area now? How do you find out this area? Let us take this distance as r and this length, this distance. Let us take this distance as pq. Now I have taken this triangle. Okay, this is a. This is RPQ. I have taken triangle RPQ. I want the area of that triangle here. Okay. So the area of that triangle which is taken as DA. So how will you write? Let us take that triangle as DA. So here DA is nothing but half into base into height. So DA is nothing but half, base is nothing but PQ, and height is nothing but R. Let us take this distance as R. This is PQ, base. See, in a curve, if you take small part, it is just like a line. You can take as a line. It is taken as a line. So base means PQ into R. So this is a small arc. Okay. So arc. In mensuration, there is one formula. If you have taken an arc which is for some angle theta or phi, what it may be. If you take this as theta, this is arc PQ and this is R. So arc PQ is equal to radius. Okay, this is considered as smaller angle d theta. R into d theta. So what is the formula in mensuration? Length of the arc is equal to radius into angle. Length of the arc is equal to radius. I have taken this angle as smaller angle which is d theta. Smaller angle. D theta means differentiated part. Small angle, very small. Very small angle I have taken. R into d theta. So what will get? Area. Half into base is PQ. PQ means R into d theta into R. So dA is nothing but half R square into d theta. Okay. So I got this formula. So how do you modify this formula into different types of formulas? I'll try to make you understand, because on this many problems are coming on Newton's Kepler's second law. Many problems will come on this. So this is very important. Now just see, I got area as half. Try to understand. First of all, area means half into base into height. Height means distance r. Half into base. Base means PQ arc, and arc is nothing but radius into angle according to mensuration in mathematics. So we write this as PQ into R into DQ into R, so R square into DQ, but I told you dA by dt is equal to constant, so instead of dA I will write half R square, d theta whole divided by dt is equal to K. So dt nenu d theta kinda pettesna, half R square. So you all know omega is equal to angular displacement by time. You can also write it as angular displacement by angular small part of angle for small time dt. Smaller angle, smaller time. So we can also write this as, okay, what do you write? You can write this as half R square omega is equal to constant. Okay, so what do you understand from this? Omega is inversely proportional to R square. Angular velocities will reduce when the distance between the planet and the sun increases. The distance between the sun and the planet increases, angular velocity decreases, because omega is inversely proportional to R square. So we got this formula. Okay, we got this formula. This is taken as formula number 1. You can modify this formula into different parts. How do you modify that formula? Let us see how to modify this formula. Next formula is, if you take that formula, I will write half like that only. R omega, I will take one more R, I will keep outside, and then like this. So half R omega is nothing but V. V is equal to R omega. the relation between angular velocity and linear velocity is v is equal to r into omega. So v into r, which is equal to k. Okay, so this is angular velocity is inversely proportional to radius. From this, you understand that linear velocity is inversely proportional to r. Angular velocity is inversely proportional to r square, and linear velocity is inversely proportional to r. Means larger the distance, lesser is the linear velocity. What is it? What does it mean here? Now this is the sun, this is the earth. This is called as linear velocity, and in this direction it is called as angular velocity, like this. So linear velocity, and this is called as a distance. Larger distance, linear velocity will be lesser. Just like planetary atomic model. Planetary atomic model. Okay. Understood what I am saying now? So, as the distance increases, velocity decreases. As the distance decreases, velocity increases, because so larger distances, lesser velocities. Okay, so with this, what do you understand? Earth is having larger velocity compared to Mars, because Earth will come first. Mercury, Venus, Earth, Mars is the next one. Mars. Jupiter is having lesser velocity than the Earth. Is it understood what I am saying now? Is it understood what I am saying now? So, if you understand, this is going to be the first formula, this is going to be the second formula, and one more formula is there. What is that? mvr is equal to L. Angular velocity is taken as mvr. So, what do you write this now? V into r is equal to L by m. Substitute here. So, I will get, instead of Vr, I will write L by 2m. Already 2 is there now. So I write like this, is equal to constant. So what do you understand from this formula? What do you understand from this formula? You will understand that angular velocity is directly proportional to mass. Larger masses are having larger angular velocities. Larger masses means Jupiter. Jupiter is the largest planet which is having largest angular velocity. Understood what I am saying now? Understood what I am saying now? Okay. So angular velocity. Angular velocity, angular momentum. L is angular momentum, no? Understood? Is it clear? Is it clear what I am saying now? So this is the total story of Kepler's second law. Three formulas you have to remember. One is half r square omega into k is equal to constant. Omega is inversely proportional to r square. This half v into r is equal to k. V is inversely proportional to r. You will get from this formula. You will get L is directly proportional to m. Angular momentum is directly proportional to mass of a body. You will get problems on this. Okay. Next is Kepler's third law. What is Kepler's third law explaining here? Chala? Huh? Okay. Kepler's third law says that this is the sun and this is the planet which is revolving around the sun. The square of time period of a planet revolving around the sun is directly proportional to cube of semi-major axis. What is the meaning of semi-major axis? I told you this is called as a major axis. In that major axis, if I take only half, this distance is called as semi-major axis. Understood what I am saying now? In an ellipse, larger length is taken as semi-major axis. Smaller distance is taken as semi-minor axis. So this half of that is semi-major. Half of this line is called as semi-minor. This is minor. This is major. Half is minor. Semi-major, semi-minor. Understood what I am saying now? So this is there now. The square of time period is nothing but cube of semi-major axis. So how do you derive this relation? So what is the explanation of this relation? How do you prove that one? Very important. Okay. So for example, this is the sun and this is any planet of mass small m. This is having mass capital M and the distance between them is small r. So what are the forces acting on that? Forces panchestunna ikkada. One is centrifugal force will act, another is gravitational force will act. These counterbalance to each other. So gravitational force of attraction between the two bodies and this is centrifugal force of attraction between the two bodies. The gravitational force is equal to centrifugal force. Gravitational force formula is G capital M. This is small m and the distance is taken as r square and centrifugal force can be taken as mr omega square. Understood? See, centrifugal force, there are two formulas. Just remember one thing here. F is equal to mv square by r of a formula, but v is equal to r omega kada. So instead of v, if I write r omega, r square by r, so r square gets cancelled. What is left now? Mr omega square is going to be the second formula. Okay, so this is going to be the first formula. Mv square by r తీసుకోవచ్చు లేదా v is equal to r omega means mr omega square you can take. Omega is said to be angular velocity, v is said to be linear velocity. Hope you understood what I am saying now. So here mm gets cancelled, so omega is equal to gm. This r comes to denominator, becomes r cube, and omega is nothing but, see, you all know omega is nothing but 2 pi by capital T. So 4 pi square by T square is equal to gm by r cube. So what are the things going to be constant here? You just see 4 pi square is constant, gravitational constant, mass of the sun is also going to be constant. Then the variables are T square is directly proportional to r cube. Understood what I am saying now? This is called as Kepler's third law. Next, now one more thing is how to find out the null point or neutral point. What is the meaning of null point? See, there is one mass which is having m1 mass. There is one mass which is taken as m2. Okay, and the centers between the two masses are joined with a distance r. Okay, so there is one point here in between the 2 points which is called as intensity is going to be 0 there. Okay, there is one point between the two masses where intensity is going to be 0. What type of intensity? Gravitational intensity. So the gravitational intensity Gi is going to be 0. First of all, how do you define gravitational intensity? Any mass you take, surrounding the mass there is a field which is called as gravitational field. If any mass, smaller mass, test mass you keep here, there is no attraction. Okay, this is called as a gravitational field surrounding this mass. Beyond that there is no attraction. When this comes inside, it will attract. There is a force of attraction. And that attraction is called as intensity. Tivrata. ఎంత తీవ్రంగా అట్రాక్ట్ చేస్తుంది. ఇక్కడ intensity will be lesser. When you go closer, intensity will increase. Still closer, intensity will increase. Outside, zero intensity. ఏం తీవ్రత ఉండదు. అట్రాక్షన్ కి తీవ్రంగా ఏముండదు. అవునా కదా? So gravitational intensity is 0 here. So how do you define gravitational intensity? So gravitational intensity is nothing but force acting on unit mass. I will define complete in a broader manner. Gravitational intensity at a point within a gravitational field is force experienced by unit mass kept at that point. So once again I will define gravitational intensity at a point within a gravitational field is force experienced by unit mass kept at that point. So anta pedda definition ki raste hai F by m naught. Understood? So what is the distance between these two? R. So gravitational intensity is G capital M, m naught by r square by m naught getting cancelled. So gravitational intensity formula enti gm by r square. This is going to be the formula. Am I right or not? If this is going to be the formula here, then here between the two bodies of mass m1 m2, the distance is taken as r, and here the point where gravitational intensity is 0. Here if you keep a unit mass m0, this also attracts, this also attracts, both are attracting. At some point it comes to rest because the attraction of this will be counterbalanced by the attraction of this body. So that counterbalancing point is called as a null point or neutral point. You have to find out that point now. Total distance is taken as r, means what is the distance? What is this distance which is taken as x here? The remaining distance is taken as r minus x. Antena? The total distance is r. This is a smaller from the smaller body. Where is the null point? You will ask, from the smaller body where is the null point? If from the larger body, what is the null point means it is becoming r minus x. For smaller body, what is the null point means it is going to be x. Understood what I am saying now? How do you find out that one? See, gravitational field intensity at this point is 0, means gravitational field intensity because of mass m1 is counterbalancing by the gravitational field intensity because of mass m2. When both are same, then only it's called as a neutral point. And the formula is how much? The gravitational intensity formula is gm by r square, is a general formula here. For this mass, g m1 by this distance, which is called as x square, g m2 divided by this distance, which is called as r minus x whole square. G gets cancelled. So what you will get now? From this you will get r minus x పైన తీసుకున్నాం by x కింద తీసుకున్నాం whole square divided by m2 by m1. Okay, so this is going to be m2 by m1. Now just see. So this is going to become r by x minus 1 is equal to root of m2 by m1. R by x is equal to root of m2 by m1 plus 1. So దీన్ని reciprocal చేస్తే x by r is equal to 1 divided by root of m2 by m1 plus 1. So x is equal to r divided by square root of m2 by m1. Okay, m2 by m1. See, m2 by m1 plus 1. For example, this body is mass m. This body is 9 times of the previous body. And now you want to find out the null point here. The distance between these two is, let us imagine, 800 kilometers అనుకుందాం. 800 kilometers ఉన్నాయి రెండు బాడీస్. ఒక బాడీ మాస్ m అయితే దాని 9 రెట్లు ఎక్కువ ఉంది. సో వాట్ ఈస్ ద ఫార్ములా? వాట్ ఈస్ దిస్ నల్ పాయింట్ ఫ్రమ్ ద స్మాలర్ బాడీ x? సో x equal to r 800 kilometers divided by m2 9m by m plus 1. So it's going to be how much? 800 divided by root 9 is 3. 3 plus 1 is 4. So 4 means 4 2s are 8. 200 kilometers from a smaller body, 200 kilometers there is a null point. From larger body, 600 kilometers there is a null point. So if you ask from larger body, whatever the value you get here, you have to subtract from this and get the answer. That is called as null point. Is it clear? So let me stop the class. Very important chapter.